We're first going to scale our parent functions through vertical shrinking and stretching. So we're going to demonstrate this on the same set of coordinate axes. So I'm going to draw a set of axes. So I've got a vertical axis and I've got my horizontal axis. Remember that your horizontal axis is your input, which is your angles. So those are your angles. And we're going to measure our angles in radians. And then our vertical axis is our output, which is our ratio. Now, normally, our function is going to go as high as +1. Actually, let me stretch this out just a little bit. Try and stretch this out. Make this a little bit. So hopefully you've caught up with me and you are drawing your axes. So I'm trying to be as accurate as I possibly can be, making my own drawings here. -1, -2, -3. Yeah, I'm going to have to bring this in a little bit, otherwise it's going to... See, I already know what's going to happen when I try and draw these. If I don't have this somewhat symmetrical, usually I do this on graph paper. So if you're doing this on graph paper, you're kind of ahead of the game. So my values below are a little lopsided, but that's okay. We're going to be able to get the point across. Now, you need to draw the harder part, which is your horizontal axis. So when I draw this by hand, I know that the period for cosine is 2 pi. So I'm going to go out here and I'm going to mark this as 2 pi. And then halfway between 0 and 2 pi is pi. And again, I want to try and be somewhat accurate. And then halfway between 0 and pi is pi over 2. And halfway between pi and 2 pi is 3 pi over 2. And this is just knowing your unit circle. So when you know your unit circle, you know that those are your axes. Those are your positive y-axis for pi over 2, negative x-axis is pi, negative y-axis is 3 pi over 2, and then the positive x-axis is 2 pi, as well as 0. And I'm going to do the same over here on the left. I'm going to go out to -2 pi. Halfway between is negative pi, and then halfway is my negative pi over 2, and my negative 3 pi over 2. So I'll be able to get two nice cycles on this one grid, so I can see not only the pattern once, but I can see it a second time. Let's start with y equals 1/2 cosine of x. Now, if you studied from the last video, you know how to graph the cosine of x. It starts at its maximum, it ends at its maximum, halfway between it's at its minimum. So we have this y equals a. Let's start with d. d plus a times the cosine of b times x minus c in parentheses. What we're working with here is we're working with a. So a describes your amplitude. So the absolute value of a is equal to the amplitude. D is where the midline is located. Now I'm going to write in there what B is, although we're not going to work with B until the next example. B affects your period. So the period is equal to 2 pi divided by B. And then we have C, and C is going to be a left-right shift, a left-right shift. we are really just concerned with the amplitude at this point. I could rewrite for you that this is equal to 0 plus 1/2 cosine of x. The 0 tells us that our midline is at y equals 0. Okay? But if you don't see that value there, you know that the midline is at y equals 0. Now 1/2 the cosine means that the amplitude is only going to be 1/2. So my maximum, rather than starting at 1 on the y-axis for my maximum, the maximum is at 1/2. And then 2 pi later, it's at the maximum again. And then halfway between, it's at the minimum, and the minimum is going to be negative 1/2. So it flattens it. It flattens it vertically. It shrinks it vertically. And then what happens between your maximum and your minimum? You're at the midline. At the midline. Let's go to the left. We start at the maximum, negative 2 pi later. We're going to be at the maximum of positive 1/2. And then halfway, when x is negative pi, we'll be at the minimum of negative 1/2. In between my maximum and minimum, we're at the midline. And now this is the tricky part. We've got to draw this curve. And it's a definite curve. And that's our graph, y equals 1/2 cosine of x. Okay, so let's compare and see what happens when we have y equals 3 cosine of x. Now our midline is still 0, but this time, let's do this in, let's pick a color I haven't used yet. So let's do this in that color green. Y equals 3 cosine of x. So our maximum now is going to be 3 units above the midline. So our amplitude is equal to 3. So our maximum is positive 3. 2 pi later, we're going to be at positive 3. So we start at the max, 2 pi later, we end at the max. Halfway between, we're at the minimum. So we have an amplitude, which is a distance from the midline to the max of 3, or the midline to the min, which is also 3. Halfway between the max and the min, we're at the midline. So the two graphs are going to share those points. Let's go to the left. Start at the max, negative 2 pi later, end at the max. Halfway between, we're at the minimum. Halfway between the max and the min, we're at the midline. And there's our graph of y equals 3 times the cosine of x. And you can see here, I'm going to show you. There's our amplitude, an amplitude of 3.